This video will be about solving systems of equations algebraically. So we have two methods to solve a system of equations by using algebra. We either have substitution or elimination. So we're going to talk about both of those. Substitution is all about replacing. Elimination is about treating the entire thing like one giant equation. So substitution, before we actually talk about a problem, if I said x equals 5, and we had 6x plus 7, we would know we could replace or substitute the 5 in where we see the letter x. Solving a system of equations algebraically using substitution is the same idea. Let's say we have 2x minus 3y. So when we're solving a system of equations, it always consists of two separate equations that both involve the letter x and the letter y. So here, this top part would be our first equation, and the bottom part would be our second equation that we're working with. And in either of those equations, we know substitution is best when we can find one letter by itself. So the letter y is the one we're going to say is the one letter by itself. We know 2x up here is not by itself because it has a 2 right next to it. 3y has a 3 next to it. And on the second equation, the reason we don't include x, even though it doesn't have a number in front, it does have this minus 1 to the side. We like the letter y because it's the only thing all by itself on one side of the equal sign. It's the only thing on the left side of this equal sign. And it doesn't have a number written in front. There is the invisible 1 there, but it's not written in. So looking at our two equations, we said the letter y is by itself. And we know what the letter y equals. The letter y equals all of that stuff over there. So we're going to do the same thing and replace. We know what the letter y equals, so on the other equation we're going to go replace the letter y with what it equaled. So instead of 2x minus 3y, we're going to replace the letter y with all of the stuff it equaled. It equaled x minus 1. We're used to it just equaling like one number. Now it can equal a lot of stuff. So now we've got to go through and solve this equation. Usually with substitution, you're going to have to do some multiplication first. The number directly in front of the parentheses will have to multiply in. So the 2x is not actually touching the parentheses, it stays by itself. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. By doing the distribution, by multiplying that, we get rid of the parentheses. So now we combine like terms. 2x minus 3x, those both contain the letter x. They are both to the left side of the equal sign. So we can combine them together to get negative 1x. The 3 and the 1 are on opposite sides, so we're not going to worry about them yet. Now we're going to do opposites so that we can get the x alone. We have to minus 3 from both sides. That opposite cancels out. Negative 1 minus 3 is negative 4. And then we have to divide both sides by negative 1. Because the final answer should just have the letter x equals some number on the other side, in this case, x equals 4. Now our system of equations, though, had two letters. It had the letter x and the letter y. So I'm going to rewrite our system over here, just so we can look at it while we're still looking at the answer. Oops, I wrote that kind of close together, so let me rewrite it. Y equals x minus 1. So again, we need to do some substitution. We're trying to find the letter y now, and we know what number the letter x equals. So I could actually pick my first or my second equation. It doesn't matter which one. I could pick either one and replace the letter x with the number 4. I'm going to pick the second equation and replace the letter x. The letter x is 4. And now I just simplify. 4 minus 1 is 3. So there are our two answers, 4 and 3. Often they'll write this as a point because every point has an x and a y coordinate. So the x coordinate would be 4 because that's what x equals, and the y coordinate will be 3. So again, with substitution, let's kind of do a recap. Let's say we have y equals negative 3x plus 5, 5x minus 4y equals negative 3. We know it's good for substitution if we have one letter all by itself, like the letter y. We take all the stuff on the other side and replace it into the other equation. Now you need some flexibility here because it could be that x is alone. It could say x equals 2y minus 5 and 3x plus 4y equals 10. If that were the case, since x is alone, when we go and replace, we'd replace into the letter x. So this second part, these are two separate problems. I'm just showing that either letter can be alone. So we'd replace and then we'd solve, and once you solve, you have to plug the answer back in. You'd have to go replace what y equaled into the equation, or if it was what x equaled, you'd replace it in the spot where x is. That means you'd have to solve for the letter y first. So again, two separate problems, just showing you how sometimes the letter y can be alone, sometimes the letter x can be alone. So next, you can solve a system of equations using substitution. Said the wrong word. Using elimination. Let's say we have negative 6x plus 5y equals 1 and 6x plus 4y equals negative 10. So if we want to solve this using elimination, the point of elimination is to treat this like one giant equation where we're going to combine each column together. Now we have to decide whether we need to add each column or subtract. So again, we have some things that can help identify, hey, this is what we should do because of the way the equation looks. I'm going to look at each variable and the number in front of each variable, and I'm going to compare them. We know that it works really well if there are two numbers that are the same, and that means we can either add them or subtract them. So looking at these two, the x's both have the number 6. So they have the same number. The y's had a 5 and a 4, so that's not helpful for us, but we only need one to match. So we're going to focus on the negative 6x and the positive 6x. When we combine these, we want them to become a 0, because that means they'll cancel out. So I have to decide if adding them together would give me 0, or if subtracting them would give me 0. So I have to decide if negative 6 plus 6 is 0, or if negative 6 minus 6 is 0. So since they are opposite signs, the best option is to add them together. A negative 6 plus a 6 is a 0, which means basically it goes away. Since we've decided to add them together, now we add each column. 5 plus 4 is 9y. 1 plus negative 10 is negative 9. Then we go and solve this. To get y alone, this is really 9 times y, so we have to do the opposite and divide. we get y equals -1. Again, with a system of equations, that's not our final answer. We still need an x value. You have to have both both letters have an answer. So again, I can pick either equation. I'm just going to pick the top one only. -6x plus 5y equals 1. I'm rewriting it just so we can see the work down below with our answer. Since we knew what y was, we actually have to do some substitution. We have to go plug in -1 into the y value. 5 times -1. And then we have to simplify. We'll have to do that multiplication part first. 5 times -1 is -5. Then we start doing opposites. I'd have to add 5 to both sides. We'd get -6x equals 6. And then we have to divide both of those by 6, or by -6, so x equals -1. Now it just happened that our answers are both -1. We know x equals -1 and y equals -1. That doesn't have to happen, but it can. They could be the same. So let me show you another example where this time we would have to subtract. 7x, I should write the whole entire first equation. 7x plus 2y equals 24. 8x plus 2y equals 30. So again, we're looking for the ones that match. We can see that we have positive 2y. So again, we want this to become 0. If I did positive 2 plus 2, that would give me 4y. That's not what we want. We want 0, so we're going to have to minus that, which means we have to minus every single thing from its top piece. 7x minus 8x is -1x. 2 minus 2 is 0, so it goes away. 24 minus 30 is -6. We want to get x alone. Even though there's a giant space, that doesn't really have to be there. It's just because we left the blank space from the y's. So if that's -1 times x, we divide both sides by -1. And x would equal +6. That's not our final answer though, because we have to go back and get a y value. I can use either of my original equations. So this time let's use the second one. Let's use 8x plus 2y equals 30. Since we know what x equals this time, we have to replace x. So we'd have 8 times 6 plus 2y equals 30. 8 times 6 is 48. Sorry, I didn't mean to drag the viewing screen around. We just bring everything else down. Right now, all we did was multiply those together. We have to do opposites, so we're going to have to minus 48 from both sides. Just bring the 2y down again. 30 minus 48 is -18. And then divide both sides by 2. So y equals -9. So our x value was +6, our y value is -9. So those are our two ways to solve a system of equations algebraically.